Let's do a simple question which will enhance your concept of orbitals. It's question number 2.25 of the NCERT textbook of class 11 chemistry. The question says an electron is in one of the 3D orbitals. An electron is in one of the 3D orbitals. Give the possible values of N, L and ML for this electron. So what the question is, it wants you is to give the value of N, means the principal quantum number, L means the azimuthal quantum number, and ML the magnetic quantum number. The possible values, because some values you may not be able to tell some values exactly. So let's see what values we can predict or tell exactly and what values cannot. So these are quantum numbers which we know as a consequence of Schrodinger's wave equation of an electron in an atom, giving its energy and its wave function or atomic or its orbitals. These are there, and the quantum numbers are direct consequence, the solutions of solving the equation for an electron having this much energy, so that there will be a corresponding wave function of it. So 3D, right? The electron is in 3D. 3, it denotes the principal quantum number. That means the electron is in the third shell. First, second, third. The electron is in the third shell. So when an electron is in third shell, how many subshells are? What are the possible number of subshells? There are 3 possible number of subshells. That means the first shell, second shell, or third shell. That means if n equal to 3, there are three possible values of L, azimuthal quantum number, 0, 1 and 2. 0 means S shell, S subshell. L equal to 1 means P subshell, and L is equal to 2 means D subshell. So when n equal to 3, there are 3 possible values of L, 0, 1 and 2, because the value of L will start from 0 up to n minus 1. One value less than the principal quantum number. N minus 1 will be 2 here. So 0, 1 and 2. 0 means S orbital or S subshell. 1 means P orbital or P subshell. And 2 means L equal to 2 means D orbital or D subshell. S is spherical, P is dumbbell, and D is double dumbbell. But it is already, it's specifically given that although for n equal to 3, there are 3 values of L possible, 0, 1 and 2, but it's specifically given that it's D orbital. Its shape is double dumbbell. So the value of L is 2. So there is no doubt about it. It's quite obvious that the value of L is equal to 2 for this electron. For this electron, the principal quantum number is 3. That means it is in a third shell. The shape of the orbital is double dumbbell because it's D. D means the value of L is 2. Okay. So now you know the azimuthal quantum number. The last number that you need to determine is ML, the magnetic quantum number, and it tells about the orientation of the orbital. Since it is a D orbital having double dumbbell shape, like spherical is like this, dumbbell is like this, and double dumbbell is looks something like this. These are the shapes of the orbital. There is a space around the nucleus of an atom where there is a maximum probability of finding an electron. It's represented by dots, right? Orbitals are the space where there's a very high chance of finding an electron. Okay, when the value of L equal to 2, what are the possible values of M, the magnetic quantum number? So we know that the magnetic quantum number, its value will start from minus L to plus L to 0. So it will be minus 2, minus 1, 0, 1 and 2. So there will be 5 values of the magnetic quantum number that we don't know, that we cannot determine, that we do not know, but there will be 5 possible values of magnetic quantum number M. And what does it represent? It represents the orientation of the orbital. If we draw the orbital picture of 3D, we use like squares. There will be 5 squares, 1 2 3 4. This represented by 3dx, 3dxy, 3d-dxz, 3dyz, then 3dx square y square to 3dyz, 3dyz, 3dx square minus y square, 3dz square. This represents different orientation in the space, right? But this is -2 means this, or -1 means this, that we cannot tell. But just represent that there will be this number represent that there will be 5 possible orientation of the orbital. It may be like this, or like this. It may be in the plane of xy, it may be plane of xz, it may be in the plane of yz, it may be in the plane of xy, it may be in the z plane, that we don't know. But these are the possible values of the magnetic quantum. These are possible values of, and these are possible orientation of those orbitals. Okay, I hope this is understandable. So in this question, we are obviously able to tell the principal quantum number, the azimuthal quantum number, but we can only tell the possible values of the magnetic quantum number, the orientation. We don't know exactly where it will be. One more thing that I wanted to add is this: these are orbitals, right? This is all the 3D orbital. These are 3D orbital, 3D orbital, 3D orbital, 3D orbital. So these are called degenerate orbitals, having the same energy, right? In each orbital there will be 2 electrons. 2 electrons can be accommodated in each orbital. This, and there will be 2, there will be 2, there will be 2, there will be 2. We do not know where this 1 electron, it might be here, it might be here, it might be here, whether it is here or here or here or here or here, it is in a 3D orbital or in a 3D subshell. Just the orientation of those orbitals are different. Fine.